This is Geometry Semester 2. It is the 6th unit, unit number 6, surface area, and it is the 5th lesson, lesson number 5, surface area of pyramids and cones and oblique pyramids and cones. It's on creatormath.com, or you might have to type in creatormath.weebly.com under the Geometry tab. The instructions are: copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. I'll model those notes for you right now. I'll pull them up and show you, and I'll even show you what page they go on. So this question asks, given the following three-dimensional shape, what is the surface area? So just to, before we pull up the notes right now, we'll pull up the notes in a second, just to orient us a little bit. This is a pyramid. It is a square base pyramid, as opposed to, you can have a pyramid with 3 sides at the base. This one's got 4 sides, and it is a square base, which means this side length is the same as this side length, called S in this case. So just to model that, where those notes are, right? Because this goes in your composition book. And you're going to, this is it right here, creatormath.weebly.com. Type that into Google, should pop up. If you go to the home page looks like this. Right, this is how you know you're on the right site. Remember, all your composition book stuff is here. There's videos on how to get an A in this class, etc. Please watch those for further information. The composition book information's here, and all the videos on the composition book. Watch those to figure out how to fill that out. But we're going to go to notes, and we're in geometry, so we're going to the geometry tab, pass by the vocabulary, and go straight to table of contents. Semester 2 is what we're in. All of this gets copied onto pages 2 through 6 of your composition book. Class setup, trigonometry unit, special right triangles unit, volume unit, conditional probability unit, circles, angles, arcs unit. Here we are, surface area. Surface area, and this is lesson 5, so we're down here at number 5. And it's surface area of pyramids and cones and oblique shapes of those types. It goes on pages 117 to 118 of your notes. And just in case this has changed by the time you're watching this, just check the table of contents for what the current is, right? My goal is not to show you what page it's on, but just to show you that these notes go on a specific page in your comp book. Here's the notes. Click that tab for notes. It'll bring up a picture of either my notes or a picture of the board if I have one. So this has got my notes. Wait for it to load because you're going to need to expand it. So these are the notes that go on those pages. Copy those in, and they're going to give us information about how to calculate the surface area of the different shapes in the problem set, right? So this is a prerequisite for you doing the problem sets we're working on now. Remember that also there are problem sets. Here's an exact copy of what we're looking at now. Here's the problems we're going through. If you could print this out if you want, I wouldn't. I would just copy these into my composition book, and I might not even go to this. I might not even open this file. I might go straight to the video solutions, which we're going to make right now and will be uploaded by the time you get to this lesson. So with that said, let's take a look at what they're talking about here, and we might even go back and look at those notes in a second, but let's see if we can figure it out first. So 2 side lengths times slant height plus side length squared. So let's think about surface area. Surface area is kind of if we had a paper, pyramid with a square base and we unfolded it. Each side of the pyramid is a triangle. So you have 1, 2, 3, and I kind of ran out of space. You have 4 pyramids, right, because it's a square base, and we have a square base. If we literally cut this thing apart and unfolded it, it would look like this. So there's surface area of that square base, and that square base has a side length S, and it's a square, so that's simply S squared, right? And they've got that right here, side length squared, so I know I've got that component. Then I've got 1, 2, 3, 4 of these triangles, so I have 4 times 1/2 base times height. There's 4 triangles, and the area of a triangle is 1/2 base times height. Why is an area triangle 1/2 base times height? Because if you have a rectangle, the area of this is base times height, and a triangle divides it exactly in half. So each of these triangles ends up being a half of the whole, or 1/2 base times height. That's how we get the area of a triangle formula, right? So we got 4 of those, and that's going to be added to this one here. So 2 side length times slant height. Well, 2 side length times slant height. So they're calling this thing side length. They're calling the slant height the exact perpendicular height of every one of these triangles. I don't really know why I'm saying 2 right here. I'd rather say 4 right here, okay? Because there's 4 of those triangles that I need to calculate, not 2. So I would make this 4 times side length times slant height, right? Oh, I know exactly why I'm saying 4 here. Look, 4 times, or 2 right here. 4 times 1/2 cancels and gives me 2. Aww. Sorry, you guys. Got a little mixed up in my own right there. So we're back to 2. So it is right. Circle this first one. And I'm glad to see that I got it right. And I'm glad to see that I can refigure out how to get it right. So this is why it changed to 2 of those, because you had 4 triangles in the beginning, but the actual formula has a half in it. 4 divided by 2 is 2, so it ends up being 2 times base times height. So 2 times base times slant height here, plus the side length squared. That's my warm-up. Takes me a while to warm up here, and there it was. So given the following 3-dimensional shape, what's the surface area? Well, because the shape is oblique, and I used to call it oblique when I was in high school, but it's pronounced oblique, you guys. Oblique means essentially, it's kind of slang to say slanted or a slant, a shape. It's pushed over, right? But notice that the base does not angle. The base stays perpendicular to the height at all times. And it does not sort of, if you just turned a shape on its side, right, that would be different than an oblique shape. In this case, the vertex up here is pushed over while the base remains still in its original orientation. Well, the interesting thing about the surface area formula for an oblique shape is that oftentimes, and it is the case in a square-based pyramid, that as long as we're using the perpendicular height can also be called altitude. It is a measurement straight up. In other words, we're not measuring the side length here. We're measuring the perpendicular height of the shape. We have the same exact formula. So we have side length squared is the, this here, side length squared gives us the area of the bottom down here, if we were to look up at the shape from the bottom, plus we have these 4 triangles. But we know, even though a triangle is, let me draw it more dramatic, even though a triangle is pushed over to the side like this, as long as we have base times the perpendicular height, or 1/2 base times height, and there's 4 of those, 1, 2, 3, 4, all around the shape, 4 times the 1/2 base times perpendicular height, as long as it's perpendicular, then this goes back to 2, just like we already said, and so we have 2 times the side length times the slant height, okay, and I would argue you might want to put a perpendicular in here, perpendicular height. We are going to come up with the surface area for the oblique shape also. So now we're switching to a cone. Given the following 3-dimensional shape, what's the surface area? So if you unfold this, right, you have this sort of shape like this. If you could unfold the whole cone, and at some point you have a circle which represents the bottom. So we need the area of a circle in here, and we have a radius. So the area of a circle is pi r squared. We know we've got one of those. Then we have this interesting situation with this whole thing, right? And what we're really doing is taking the pi times the radius times the slant height. And for this one, I would direct you to the notes. Let's go back and check just to model what this should be, because you should have put these notes in your comp book first, right? Let's take a look. And as long as they load right, you guys, sometimes I have to reload these several times. So surface area of a cone and slant cone. Slant height, right? So that's the distance along the edge of this thing, times the pi times radius times slant height is the formula for the surface area of that part of the cone, right? And I don't think we derived that here, do we? Let's see. Pull this up. Yeah, we don't. We're just going with that. So use the notes to follow this, and we're going to take pi times radius times slant height. So pi times radius times slant height plus the area of that circle, pi r squared. And that's going to give us the surface area. the interesting aspect and one of the points of this lesson, that is, even though we have an oblique shape, as long as we are using the perpendicular height, pi times radius times slant height in this case, is going to be this length here, pi times radius squared. We're going to end up with the exact same formula for surface area, even of an oblique cone. Oh, and that's all they want us to do in this one. So match up this lesson with Geometry Semester 2. It's the 6th unit surface area, and it's the 5th lesson surface area of pyramids and cones. Hope that helps.